Welcome, everyone, to the third technical workshop of AO Ventures. I'm here with Lorimer, who is our Arweave and AO engineer that'll be conducting the technical workshops throughout the program. I'm sure you guys are familiar with him already if you've seen a couple of the other ones. Today, we're going to be diving into AO and the fundamentals of parallel processing. And once again, if you guys have any questions, feel free to ask them in the comments, and we'll try to answer them all once the presentation is complete. With that being said, I'll pass the mic to Lorimer and we can get started.
Oh, well, thanks very much, Jesse. We are now on the third workshop. So this is a introduction to AO. Right now we're in a really, really good place with Arweave, I think. We've learned about like Arweave's consensus mechanism. We've learned about wildfire, gateways. We've gone into like the ecosystem wallets, the SDKs, sending Arweave, retrieving data off Arweave, uploading it, bundling, lots of different concepts in Arweave. Now we're going to do exactly the same thing, but for AO. This presentation is going to be like a tiny bit of theory and then a tiny little bit more development stuff. I think from the feedback I got from the first one, we want to hop straight in with like development stuff. Without further ado, this is the introduction to AO. What we're going to achieve, like an understanding of what AO actually is, compare AO to like a traditional decentralized compute environment, something like the Ethereum virtual machine. Go over AO's core infrastructure, processes, messages, and what SUs are, CUs and MUs. They may sound very complicated right now, but I assure you they're not. Go into a introduction of what AOS is. Cool. Before I begin, definitely going to give credit to the AO cookbook for a lot of this stuff. I really recommend it if you haven't gone through it. Definitely go through the AO cookbook. Don't get it confused with the Arweave cookbook. Arweave cookbook and then AO cookbook. In a nutshell, the AO computer is a parallel decentralized computer. So what does that mean? Basically, what we're trying to build with AO is a way to run like scripts on Arweave. As you kind of saw in like the previous presentations in Arweave, like we have the ability to kind of upload data, retrieve it, send tokens, and do all these really cool things. But I'm sure you guys noticed there wasn't really a way that we could run scripts on Arweave. There wasn't really a way that we could like actually put our backend infrastructure on Arweave. We can kind of just like trade tokens with each other and things like that, which is super cool. But how do we actually build dApps, like true decentralized applications? This is where AO comes in. AO is a little bit different from like most other ecosystems. There's some really cool stuff that it can do compared to other blockchains. Like one thing is like parallelizing. Basically running scripts in parallel with each other. Like in normal blockchains, you kind of have to do things like one after the other, right? So say you had like a script that basically checked for like deposits. And so when one deposit happened, you do like a certain action. Then you'd have to wait for another deposit, and then you do another certain action, and you'd have like things go like sequentially. So like do that, do that, do that, do that. This is super, like, is fine doing it this way, but it can kind of be like slow, and you're very, very limited to the dApps that you can build. I think there's a reason why in Web3, like, there's a really, really big difference between Web2 apps and Web3 apps. And I think it's partly due to you kind of can't do things at the same time. So in AO, you can do things at the same time. You can kind of say, oh yeah, if this deposit happens, we'll still complete all of these tasks that we're going to do after, but while we're waiting on the deposit in the contract, we'll also get these other things done. So you can kind of like do actions at the same time, which again is super cool for when you're trying to build things like bots. Trying to do lots of different things at the same time opens new possibilities. It's a little bit different in AO. I'm sure you've kind of seen that. I haven't used like the word contract here. In AO, we use something called a process and messages instead of transactions. In a nutshell, basically, AO is like a new layer 2, a new smart contract ecosystem where they're called processes and messages. And yeah, basically you can do lots of things at the same time. I'm sure you've seen like the hyper parallel computer. So yeah, basically smart contract ecosystem where you can do things at the same time. So you're kind of thinking, how does Arweave come into play? Like we're going like heavy into Arweave within the first presentation, so now we're going into AO. So Arweave is, I mean, AO is actually built on Arweave. So we have Arweave as a layer where you can upload data and retrieve it, etc. But AO is like a layer that kind of sits on top of the Arweave layer. So Arweave is like a layer one network, right? And then AO is a layer two network that sits on top where you can build like actual applications and dApps. So yeah, it's basically a proof of stake network on top of Arweave. So instead of like when we're going into Arweave's proof of access, it doesn't use the same consensus. AO works in a way like there's lots of different nodes that all are like are going to be in. We're in testnet right now, so most of the nodes aren't out. But when they are, they'll basically be on a consensus called proof of stake, where each network will have to stake like an amount of funds. Basically, if they do something wrong, they get slashed, and if they like continue to do well, they get rewarded. So it's very, very different to proof of access. But yeah, proof of stake network on top. So yeah, you're kind of thinking like, a person coming in from like Ethereum would kind of think, why don't you just use Ethereum? What's the point of using AO? Well, now we have the ability to do things like, run scripts on Arweave. We can also take these scripts and utilize Arweave itself. I think one of the reasons why this is like AO is so cool that it's built on Arweave is we can also get access to permanent data storage through AO. If AO was like a separate thing, we wouldn't get access to Arweave's features. We'd have to build like a bridge between the two different networks. And that's really, really annoying. The last thing we want is to be building an ecosystem and to like interact with another one, we have to rely on another protocol to build that bridge. If you think of it in Web 2, imagine you were building a website in, say, JavaScript, right? You've got like a basic like React website, and then you have like an HTML website. It's kind of like the same thing. Like you can interact and send messages and like requests between these two different websites. But like in traditional crypto, you can't do that. Like you can't really send a transaction between two different blockchain ecosystems, like from the get-go. You have to rely on another project to do it. So yeah, AO is super cool that being built on Arweave, we can access all of Arweave's core features as well. So yeah, another thing to mention is as Arweave is built, as AO is built on Arweave, we can get access to like the permanence of Arweave. So all of our transactions are actually saved forever. So if I made like a token interaction between myself and like another AO process, that interaction is now permanent forever. Unlike in other ecosystems where it's not, I'm sure you guys have kind of heard if you're Solana native. And for a while, Arweave was actually like some of the Solana data was being stored on Arweave, which was a really, really cool sign of early product market fit for Arweave. But for Solana, like it didn't look too good because who's to say that in 100 years, like if a DEX swap really happened, if like how did tokens get in someone's wallet if all of like the data is not stored like permanently? So yeah, AO's got a lot of cool things going for it. So in AO, you basically code all of your scripts in a language called Lua. Lua is like a really, really lightweight language, and yeah, I can kind of tell what you're thinking. If you didn't know this, you're like, oh, I'm gonna have to learn another new, really complicated language. Like going into, I first learned really Web3 and Ethereum, and had to like learn Solidity before I could even code like JavaScript or Python. I was having to muck about with Solidity, and it was great for me as a dev because I kind of got like learned some good concepts. But then wanting to move out to other ecosystems, say like Sui, for example, I'm gonna have to learn like the Move language, or if that might be Aptos. But yeah, I'm gonna have to learn a new language, and if I go into like Polkadot, I'm gonna have to learn Rust. It's like super annoying whenever you go into different ecosystems, you have to like learn a whole new language. But Lua is quite nice in the sense that the language is super, super simple. If you can code in like Python or JavaScript, you can pick up Lua like in a couple of hours. So yeah, it's super like lightweight as well. When we're building like backend apps, the last thing we want is like a massive node modules file. Whenever you build like a like a React app, and you have like a node modules, and I'm sure that you've seen the joke if you're a dev, like junior devs uploading the whole of the node modules file to GitHub, and getting told off, and it's like super super big. Imagine if every dApp had to have that on a blockchain. Sending one transfer transaction is bad enough, but imagine like a whole node modules like folder. So it'd be ridiculous. So Lua is really cool in the sense that it's super lightweight, and you don't have a massive node modules file that comes along with it. Super super lightweight, and yeah, very very similar to like Python and JavaScript, as well as it's fast, and yeah, very very quick to learn. So let's dive into a little bit of AO's infrastructure. So, now we know that, we've got Arweave, the layer one, and we've got AO, the layer two, that basically sits on top. So we code in Lua, right? But how does AO actually work? So into these things called like MUs, SUs, and CUs. So kind of sounds a little bit complicated, but these are basically pieces to a puzzle that makes up AO. All of like AO revolves around these things. So very, very simply, an MU is a messenger unit. So the purpose of a messenger unit is basically to handle the incoming and outgoing messages that are basically sent on the network. So if you kind of think of it, we're proof of stake, we've got lots of different nodes in the network. This is how like all of the transactions and things are retrieved, how what like transactions are being sent, and we basically end up with like a big lump of transactions from the messenger unit, basically handling all of those transactions coming in and out. So once we have them, we need to be able to order them. This is what a scheduler unit does. So yeah, people kind of think like about sequencing. It sounds super complicated. Like I remember when Warp first came about, like in Arweave, we had this, we had like a smart contract environment called SmartWeave. Then we had a project came along called Warp that basically made something called a DRE node. A DRE node was a designated resolution environment, basically like an early version of what these units are now. And you'd have like DREs that would sequence, and they got really good at this. But I remember thinking like, transaction order and sequencing sounds super complicated. So like in the most simplest way, if you have like lots and lots of different transactions, right, you need to know what transactions came first and what transactions came last, because I could send like a token to Jesse, and then Jesse could send one back. If the node didn't know which one happened first, who's to say that I even sent Jesse the transaction first? Maybe I can just say, oh, well, I sent money to Jesse and he didn't send it back. Like super, super important. Basically, once we've got all of these different transactions and messages from the messaging unit, to basically order them correctly. So yeah, that's all the scheduler unit really does. So once we've got that, we basically need to go into something called a CU, a compute unit. So we've got all of these different, we've got imagine like a massive long list of all of these different transactions that have happened in a really, really nice order. We basically need to figure out and compute the state of what happened with these transactions. We need to work out what, code we actually want to run. We need to execute some code. So yeah, that's basically what a compute unit does. And yeah, really, really simply, you basically have these 3 units in a node, and they basically make up AO. So you may have heard me mention processes and messages. Yeah, in AO, you don't have like contracts and you don't have transactions. Transactions, I like to think like are super bulky and super expensive. Contracts as well, super hard to deploy, super hard to code. It's very intimidating going into like a new ecosystem and trying to even just deploy a contract. So in AO, we like to do a little bit differently. Processes are basically like a process of how you run a script. So whenever we deploy like a process on AO, we're technically deploying like a script, like a contract. So yeah, very, very simply, you have like a, Lua script that, did a lot of different things. Say it was a DEX, you had like a Lua script as a DEX. You deploy that as a process. And then people that want to interact with that process, you send like the process a message. A message is like super lightweight, array of data. So in a message, there might be like some data you want to put into the DApp. There might be like a timestamp of when you sent this message to the contract. It's just lots of little like information, much like a transaction, but super super lightweight. So yeah, with messages and processes is processes can actually send messages to other processes. Um, and so it's super cool. You kind of get like a like connected contract type vibe. Instead of like the old stagnant way of doing it, that you take a user that interacts with a contract in Ethereum and waits for a response. You can have a transaction sent to a process, and that process be able to send another message to different processes. So yeah, super lightweight and a super cool way of like interacting with other dApps in the ecosystem. And yeah, this is actually built on from the ANS 104 data item upgrade that I was basically telling you about with bundling. So not only are they like super lightweight from like the data perspective, they're super lightweight from the network's perspective because all of the messages and all of the processes are like bundled. If we go back into that analogy of like we have 100,000 floppy disks versus like one USB drive, like we can get super 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 lightweight data being shared across AO. So we kind of now in a position where we've got this like layer two that has lots of different processes on, that has sending lots of different lightweight messages to each other. We have a network that's proof of stake. We have all of these different nodes laid about with all of these different like compute units, scheduler units, messenger units. Sounds super cool. But what's the difference between an actual like if we go into another ecosystem between their like contract environment? So yeah, usually they run on like something called a virtual machine. I'm sure you've heard the term being thrown about a little bit, like EVM, Ethereum virtual machine. I think even Solana's got like a virtual machine. Yeah, they're basically like compute environments that are sharded across lots of different nodes. This is a super super expensive, slow headache of of like doing like decentralized basically a decentralized ecosystem. It was like a really cool initial vision, but it doesn't have to be that complicated when you put something like Arweave into the mix, because you can get permanence. All of these different nodes in AO basically are now like highly incentivized to use these different units to basically get a really good state of the AO network, because if they don't, because it's proof of stake, they would get like slashed. They would get they're de-incentivized to basically do this. So basically means you can get lots and lots of different lightweight nodes that don't have to run a whole virtual machine, that don't have to like have really really high like RAM on their laptops, don't have to have really really high like you know latest NVIDIA chips, like expensive AWS services. You can get really lightweight nodes, which is great from an ecosystem and decentralized perspective, because they are all incentivized naturally through proof of stake not to like misbehave in the network. But it also means like anyone can kind of spin up a node like in a super lightweight way. You don't have to run like a full clunky virtual machine node. You can run a really lightweight node that basically all it does is retrieves transactions off Arweave, computes a state, and sends back a result to the user. You can kind of think of these like nodes much like gateways. If you remember going back into like what Ario is and how like gateways work and stuff, Ario have really forefronted easy ways to retrieve data off Arweave. So like you building upon what they've kind of done with that, we can take really really lightweight AO nodes, use the same technology, basically retrieving data off Arweave, and then serving a response to the user. So yeah, super super cool. But one of the best things about doing it this way is it's great from a like architecture standpoint for integrating different coding languages. At the moment, we're just in testnet. So we just use Lua. Lua is very, very lightweight, very good, to get things up and moving. We don't have to do very, very complicated like state management and things like that. But the way this has been architectured, we can actually have any programming language when you think about it. The core tech here is really just like putting data on Arweave, computing like, what we want to compute in a DApp, and also like retrieving messages, trying to figure out the state of a contract, who's transferred to who has how many token balances. It's not like dependent on a coding language. So like theoretically, we can have Rust based AO, we can have like a Python based AO, we can have a JavaScript based AO. So yeah, super cool how it's architected. So you're kind of thinking like we've got this whole different network. Now I'm going to have to use like a whole like annoying SDK to interact with all of it. I'm going to have to relearn everything. No, there's something called AOS that you might have heard of. It's basically a CLI tool where you can like deploy processes, where you can interact with processes, where you can like await responsive processes. And yeah, kind of like an all-in-one developer like tooling for using AO. When I first heard about this, I was like, I'm a Web3 smart contract engineer. Like, I am really, really used to having to make scripts to deploy contracts. It's nothing worse than when you're like excited to get into like a new project and you have to spend half of it copy and pasting previous scripts from other like courses and examples and apps and stuff, when you just want to build your thing. So with the CLI tool, you can deploy a contract like straight away. It's super, super simple. You basically open up AOS. I'll show you in the next workshop, but you open up AOS, like one command, like deploy, script.lua, and you're away. You get a transaction ID back and it's done. Like your computer's file system takes care of like where the actual like script is being stored, etc., and just deploys it straight away. And then building onto that, once you have the script deployed, you also have like environment variables in AOS. So like a really nice developer experience thing they've done is if you do something like AO.id when you boot up AOS, it actually like saves the current process that you're in. Kind of think of it, instead of interacting with a process, imagine the process is there with you in your machine. It's there with you. You're kind of inside the process as soon as you boot up AOS. There's none of this business, sending transactions and awaiting responses and trying to debug it that way. You're actually in it live. So you can see all of the transactions going in and all of the transactions going out. So say you sent like a message to this process you've just deployed. When a response message comes back in AOS, you actually see it in the terminal saying new message from whatever. So yeah, super, super nice developer experience. Again, I was like super like in the beginning, like, oh, I don't know about this. I'm not really like using like CLIs before, but no, super, super nice way of doing it. So I'm kind of at the stage now where we like using AOS for deploying contracts as like a developer, like being able to test certain interactions, see if they work. We've got all of these different environment variables where we can like store data that's, like we're dependent on for our app. Say it was like an example transaction, we can store that in the actual CLI itself. How do we actually interact with the process we deploys themselves from a client? How I envision a world where I can have a DApp where the the website is basically made in React. It's deployed with drag and deploy, and it's on Arweave. I can retrieve it through an ANS name. How do I then take that DApp and still be able to interact with AOS in a super decentralized way? So this is where AO Connect comes in. It comes in. Think of it like a like basic like TypeScript library, where you can in TypeScript basically send messages out of the client, as well as like spawn processes. So spawning is like a new thing. So instead of like having to redeploy like a whole process, from the CLI with the script in your VS Code or whatever, you can actually spawn a process, basically copy and paste it again. So it again enables lots of different dApps to be built, where before you would have to like take the actual code and redeploy it, and this can be super annoying when you've got a really, really large dApp. When I was first building Authent that while ago, our initial idea was basically every user would get like their own smart contract as a wallet. So they'd all have like an individual smart contract, and they'd only be able to access this contract if they provided something called a JWT. So it was a super interesting way of, instead of using a wallet, you have like a smart contract wallet. So when I was building this, I would have to like redeploy the whole like code itself from like a server, and that was really annoying. I can tell you, like the amount of times, like in like modern day servers, sometimes even just to like trust the code that you're redeploying is the same code that you initially deployed when you first made your DApp, is like, you can't always trust that. So with AO, you can trust that because you can redeploy from a transaction ID and spawn a new new process in. So yeah, super super interesting way of being able to do it in the client, which also means you can do it with something like drag and deploy using an ANS name, so it's super super decentralized. So now we're going to go into something like called crons. Crons again are a new concept to the smart contract world. Really really simply, all a cron is, and it sounds again like super super like weird, like what is a cron? It sounds like a British sandwich, like, oh, I'm going to go and have a cron, with my with my scones. But yeah, a cron is basically a way that you can send like a message to your process that you deployed to get it to do an action again. So what do I mean? I kind of think of this like a for loop. In a for loop where you have like a function that's triggered again and again and again and again until you get like a correct result. Well, a cron is a little bit different, where you can trigger like a process again and again and again to do a certain thing over a certain period of time. So you can set a cron to basically run, say, every 5 minutes to do a certain action in your process. Like a really good example of what this enables is something like a trading bot. If you look in Ethereum, you have like things like Gelato Network, right? Which are a little bit expensive, but a cool idea, but expensive and hard to use in practice. Where you can like send multiple interactions to a contract to get it to do a certain thing, lots of different times. But sometimes these are unreliable. So with a cron, if you set up like a trading bot to make a trade or to look for a trade opportunity every 5 minutes, that's a super cool idea. So yeah, using crons, you can do a lot of different things, as well as for all of you projects, building things with AI. If you have a little look on the AO Twitter, you're going to see like the term, or even if you look on AI Twitter right now, you have like all of these autonomous agents, they're called. The idea is to basically take like a large language model and basically make it run like, or autonomous. So you don't have to run it physically in like a server. It can just run forever and yeah, grow more clever and do more things. So this idea is super cool, but it's yeah, super hard in practice because really it's like not autonomous. It's just running on like an Heroku server. Like it's basically still running. You can turn it off. But with something like AO, if you have like a permanent decentralized compute network where you can build things like bots that can run forever, every 5 minutes, you can build a true autonomous agent and true web crawlers that like really get clever and do all of these different possibilities. So yeah, very very interesting idea. And yeah, there's a few of you like working on AI, and we've spoken about like putting large language models on AO. I really encourage any of you guys that are wanting to pursue that to definitely try and do that, because it will be very very interesting to get a Web3 network that is permanent, where you can have autonomous processes built in to the network, and run large language models on them. Very very interesting concept. It could be like a kind of let the cat out the bag, or whatever the saying's called, but super super cool idea. So little recap. Yeah, AO, hyper parallel computer, basically a like smart contract environment where we don't call them contracts, we call them processes that can also interact with each other through something called a message. Proof of stake, that have all of these different like nodes that basically work out the state of the network. If they misbehave and like do a mismatched state of how the network currently is, they get slashed, they get told off. We've got Arweave that basically is the layer one for the whole of this. We can utilize all of Arweave's features that we've gone over in the previous workshops, permanence, all of these different like concepts of deploying apps, making transactions using like wallets. But also have like autonomous processes. We can like build like full scale dApps in Lua. We can build DEXs. Like we can do all of these really cool different things. Yeah, we've got Lua itself, super super lightweight, super easy coding language to learn. If you like, you've learned a little bit of Python, a little bit of JavaScript, which most of you have. We've got messenger units, scheduler units, compute units, which basically are the underpinning of all of the pieces to this AO puzzle. How it really works, like how all of these transactions are ordered, how we figure out the state of the network. And yeah, we've got like we little touch on like virtual machines, comparing them to virtual machines. AO is a lot more scalable. We can do a lot more like different things. We've got AOS, super super nice from a development point of view. You do not have to like have all of these different deploy scripts, all of these different scripts that check if a transaction's done something. Last thing any developer wants to do is write a test, ingest. No one wants to write tests. Tests are horrible, but we have to do it in our contracts. But we do not have to do it now when we're testing what happens in our contracts. When we're just trying to look, if we send a transaction and we get a response like a ping and a pong, we can see it in the CLI, which is super cool. Then yeah, we went over AO Connect, how we can actually take a process that's being run in an autonomous way, how we can like from a client basically interact with that process, get a response back. And yeah, crons. As you can probably tell, super excited about the idea of crons. So yeah, thanks very much. Basically, that was an introduction to AO. In the next workshop, we're going to be going over some fundamentals, and yeah, building on the dApp that we built in the previous one, but actually connecting a process to it. We'll touch on a little bit about crons, but hopefully I've got you thinking about like, different ways you can architecture the dApp, different features that you can like use outside of different Web3 ecosystems. Definitely a lot to be thought about. One thing I've started doing recently is, most of you guys on this call right now are founders. Being a founder, you're meant to found a new concept. It's not about like, not necessarily reinventing the wheel. If something works, it's great, but you do not have to do it like you do in other ecosystems in this ecosystem. You can architect things different ways, which enable new features and new designs and like much better like things for the user at the end of the day. So yeah, would definitely recommend checking out crons, checking out like AO, checking about like doing things in parallel. And yeah, building with Lua, all of these different concepts. So yeah, stay tuned for the next one. And yeah, I'll pass it back over to Jesse.
Amazing. Thank you, Lorimer. I learned a lot from that. Looks like we got a lot of questions. I will read them to you and we can go through them one by one. And then we'll wrap up. So first question is from Mark, and he says, can my AO process directly read in data from an Arweave transaction or write an Arweave transaction?
It's a good question. I know they can retrieve data. I know definitely it can retrieve data. I don't know about writing data to Arweave, but that is a feature that I know like would be really, really good. So I'm pretty sure there is a way. If you let me have a little think, can try come up with some Lua code the way you'd be able to do that. I imagine like an easy way of doing it would be to, use like an Oracle system to be able to like communicate back to your client web app or something like that. Do it that way. But yeah, I'll try and figure out a way, but I imagine there will be a way, yeah. To write data
post that. We can post that in the Discord later for anyone who's interested in getting more clarity. And how to implement an autonomous process on AO that runs even when I turn off the laptop. Do we have to set up and pay the servers ourselves for it to run autonomously?
Yeah, I think right now crons are free. I think this whole testnet is free, so it's all being like subsidized by Forward Research at the moment. I don't think they've mentioned anything yet about if they're turning off this subsidization feature. But yeah, you would basically boot up something like AOS, set a cron to like run, And yeah, just have that AOS process running and like make sure like the cron is like still active and stuff like that. So yeah, you basically just boot up AOS, set up the cron, and then that will like continuously run for however long you want the cron to run for.
Great. And for Warp, would AO be replacing the need for Warp in our projects?
I don't think so. I first learned to code in this ecosystem with Warp. Um, I think Warp has different advantages over AO. One of them being that you can code in JavaScript right now. So if one thing I'm saying to teams, if there's no reason to change it, don't like that. This like focus just on the MVP about like your core product. So yeah, if Warp is like servicing your needs right now, I don't think there's any reason to change it. But yeah, I don't know. I think they're going to announce something soon. I think. So I definitely stay tuned for what they're going to announce. But yeah, if it's not broken, there's no point in fixing it.
Right. Um, and replying to not needing expensive hardware like NVIDIA to run a node, is there something that stops users from running long compute heavy processes?
I think it's like so it's like on a spectrum. It's like how powerful do you want your node to be? If you want one node to control of the whole of AO, you're going to need a pretty powerful node when the state gets like super big. But if you only want a node to like service a tiny part of the network and only work out like certain things, you don't have to. So yeah, it's kind of like a spectrum. You can have a super heavy node. Also, you can have a lightweight node, but yeah, the kind of comparison is in like an EVM world, you'd have to have a super heavy node. So even like be in imagine if it was Bitcoin. Imagine the amount of like the GPU and NVIDIA chips you would need to even get chosen to mine a block. So it's kind of nice in this ecosystem that you don't necessarily have to be Jeff Bezos to run a node.
Um, and you mentioned 5 minutes with messages crons, but that sounds too big an interval for general autonomous agents. Is this interval limited by the computational resources?
Yeah, you're right. 5 minutes would be not very good. I think you can run crons up to like 1 second. It's like a parameter you can set yourself. You can run a cron that's 1 second. You can run a cron that's 100 years. So yeah, crons are super versatile. You don't have to do 5 minutes.
Okay. And following up on Mark's question, so this was the question about AO processes directly reading in data from an Arweave transaction and writing Arweave transactions. Can we query Arweave like GraphQL from an AO process, and if so, what is the limit?
Can you query? I don't know if you can query via GraphQL. GraphQL basically you've got GraphQL is basically like a super efficient way of querying data on Arweave because I'm pretty sure it's like pre-indexed. So the only GraphQL people right now in Arweave are Arweave.net, which is Oreo, and then Goldsky. I'm pretty sure. So they're the only two endpoints I know that index Arweave and you can do GraphQL. But that's not to say you can't use these services in AO. It would just mean you need to use an Oracle to basically interact with them. So like there's this project called Orbit. Please don't shoot me because I'm pretty sure they're being incubated by this ecosystem. But their whole idea is basically being able to send requests in AO to outside servers. So theoretically, yes, you can query Arweave data through GraphQL on AO.
Great. That looks like all the questions. We'll wait here for 10 more seconds and see if anyone else asks anything. Okay. I think we can wrap up. Again, thank you, Lorimer. That was great. I'm looking forward to your next and final technical workshop next week, where we're going to go even deeper on AO, I believe. And this Thursday, we're also going to be hosting our second keynote presentation from a very seasoned builder in the Arweave ecosystem named Tom Wilson. And I know he's going to go over a project and really dive into AO and AOS as well. So definitely stay tuned for that. Be sure to register for all the events. Anyone who signed up for AO Ventures on the website is on the mailing list. So definitely make sure to do that if you haven't already. And thank you all of you for being here. It's great to see everybody in the chat and asking questions and participating. So it's really nice to see. I'll see you guys on Thursday. And cheers, guys. Thanks, Lorimer, again.